Good day, everyone, and we are the Group 5.
Today, we are going to talk about areas prone to hazard and coastal processes. Objectives. First, identify areas prone to hazards brought by tropical cyclones, monsoons, floods, and ipu-ipo. Second, describe how coastal processes result in coastal erosion, submersion, and saltwater intrusion. Contents. Hydrometeorological phenomena hazard. Second, marine and coastal processes and their effects. Number 3, prevention or mitigation of impact land development, waste disposal, and construction of structured and coastal processes.
So, let's start.
What is hydrometeorology? Hydrometeorology is a science that studies the cycle of water. The hydrometeorology studies the process of hydrological cycles that occur in the atmosphere: evaporation, condensation, and precipitation. Ocean and seas significantly impact continental weather by absorbing solar energy, primarily through evaporation. This evaporated water rises into the atmosphere, condenses to form clouds, and ultimately leads various forms of precipitation.
Hydrometeorological hazard, a process of atmospheric, hydrological, or oceanographic nature that may cause the loss of life or injuries, property damage, social and economic disruption of environmental degradation.
There are different types of hydrometeorological hazard. Number 1 is tropical cyclones. Number 2, hurricane. Number 3, cyclone. Number 4, typhoon. Number 5, monsoons. And lastly, ipu-ipo. So what is tropical cyclones? Tropical cyclones are warm-core low-pressure systems that form over warm ocean waters, deriving energy from the heat released during condensation. They can develop only in ocean, typically at latitude greater than 5 degrees from the equator. Their intensity peaks over warm tropical waters and weakens when they move inland, often causing significant destruction.
These occur in a continuous process, not as separate and distinct stages. Each stage may occur more than once during the life cycle as the strength of the cyclone rises and falls. It may reach land, weaken, then go back out to sea where it strengthens once more. The formation of a cyclone depends upon the following conditions coinciding: a large, still and warm ocean area with a surface temperature that exceeds 26.5 degrees Celsius over an extended period. This allows a body of warm air to develop above the ocean's surface. Low-altitude winds are also needed to form a tropical cyclone. As air warms over the ocean, it expands, becomes lighter, and rises. Other local winds blow in to replace the air that has risen, then this air is also warmed and rises. The rising air contains huge amounts of moisture evaporated from the ocean's surface. As it rises, it cools, condensing to form huge clouds about 10 kilometers up in the troposphere. More warm air rushes in and rises, drawn by the draft above. The rising drafts of air carry moisture high into the atmosphere, so that these clouds eventually become very thick and heavy. Condensation then releases the latent heat energy stored in the water vapor, providing the cyclone with more power. This creates a self-sustaining heat cycle. Drawn further upwards by the new release of energy, the clouds can grow to 12 to 15 kilometers high. The force created by the Earth's rotation on a tilted axis, the Coriolis effect, causes rising currents of air to spiral around the center of the tropical cyclone. It is at this stage that the cyclone matures and the eye of the storm is created. As the air rises and cools, some of this dense air descends to form the clear, still eye as the cyclone rages around it. The eye wall, where the wind is strongest, behaves like a whirling cylinder. Cyclones rotate clockwise in the southern hemisphere, anti-clockwise in the northern. The lowest air pressure in a tropical cyclone is always found at the center and is typically 950 millibars or less. The average air pressure at the Earth's surface is about 1010 millibars. Tropical cyclones have significantly lower air pressure than the air that surrounds them. The bigger the pressure difference, the stronger the wind force. One of the lowest air pressures ever recorded was 877 millibars for Typhoon Ida, which hit the Philippines in 1958, where winds reached 300 kilometers an hour. Once formed, the cyclone's movement or track follows a pathway away from its source, driven by global wind circulation. As warm ocean waters feed it heat and moisture, the cyclone continues to enlarge.
Hurricane. A hurricane is a powerful tropical cyclone characterized by strong winds, heavy rainfall, and well-defined circulation patterns. It forms over warm ocean waters and can cause widespread damage and destruction when it makes landfall.
Hurricanes are the most violent storms on Earth. They form as waves coming off the coast of Africa. Like all tropical cyclones, a hurricane needs the warm water of the tropics, which feeds a storm with energy in order to form. The warm water then helps fuel the system, providing energy that causes the warm air in the center to rise faster. It condenses high in the atmosphere, creating thunderstorms. If conditions are favorable, a tropical depression develops into a tropical storm, and then finally, a hurricane. As rising air in the storm's center condenses, it produces heat, forcing it to rise even faster, pushing air out the top, and more air has to rush in at the surface to take its place. The pattern allows the storm to essentially feed itself and grow in strength. Because of the Earth's rotation, all hurricanes in the northern hemisphere rotate counterclockwise. The most destructive section of the storm is normally in the eye wall area to the northeast of the eye. This is the area that causes the most destruction when a hurricane makes landfall, leading to higher winds and storm surge.
Cyclone. A cyclone is a large-scale atmospheric system characterized by a closed circulation pattern, typically spiraling inward and upward. It can refer to various types of storms, such as tropical cyclones, which includes hurricane and typhoons, or extratropical cyclones, common in mid-latitude, bringing precipitation and changing weather patterns.
Cyclone is a general term used by meteorologists to describe any rotating, organized cloud that originate over waters. Cyclones, hurricanes, typhoons, one event but different names depending on the location. In the Atlantic and the Northeast Pacific, it is called hurricane. And in the Northwest Pacific, it is termed as typhoon, and in the South Pacific and Indian Ocean, it is called a cyclone. You can also classify them based on hemispheres, the northern ones as hurricanes and the southern ones as cyclones. There are also a few other differences in them apart from where they originate, like the cyclones are usually clockwise, but the hurricanes are usually counterclockwise. Where do these cyclones originate? When the atmospheric pressure is low over a large water body that is still and the temperature of the water is more than 26.5 degrees Celsius, then they form into a cyclone. Before getting into any deeper, let us understand what is atmospheric pressure in general terms. The density of air in our atmosphere differs from place to place. They are not the same everywhere. Atmospheric pressure is the weight of air acting against the surface of the earth along with gravity. Air in the atmosphere creates a pressure on Earth's surface called the atmospheric pressure. Atmospheric pressure is more on the Earth's surface, and as we move upwards, there is less amount of air and hence the atmospheric pressure decreases. When there is low atmospheric pressure on a large water body on Earth's surface, they turn into a cyclone. This process of thin air circulating, strengthening and developing into a cyclonic formation is called cyclogenesis. So how does it become a huge, stormy, cloudy cyclone? When the atmospheric pressure is low, the warm air rises to fill the gaps and the cold air goes down as they have moisture in it. The warm air, as it reaches the place, it becomes more warm and it rises rapidly, thus creating more gap. So the surrounding air rushes in to fill the place. These filling air travels at greater speed and from longer distances. When they reach the area, instead of filling the gaps, they start circulating and thus creating a spiral. After that, any air traveling to fill the gap has to join the spiral because the air cannot pass through the spiral directly. Usually, tropical cyclones range from 100 kilometers to 2000 kilometers in diameter. When a large amount of air is rushing in to fill the gap, they form huge cyclones and the spiral structure becomes larger and larger, penetrating the clouds and thus creating thunderstorms.
Typhoon. A typhoon is a term used to describe tropical cyclone that occurs in the Northwest Pacific Ocean. It is essentially the same meteorological phenomenon as a hurricane with a different regional name. Typhoons are characterized by strong winds, heavy rainfall, and well-organized circulation pattern, and they can cause significant damage and impact coastal regions when they make landfall.
Now, how do typhoons form? Typhoons form over the warm ocean water of the tropics. When warm, moist air over the water rises, it is replaced by cooler air. The cooler air will then warm and start to rise. The temperature difference between the warm, rising air and the cooler environment enhances the upward movement of the rising air. This cycle causes huge storm clouds to form that will begin to rotate with the spin of the earth, forming an organized system. If there is enough warm water, the cycle will continue, and the storm clouds and wind spins will grow, causing a typhoon to form.
Monsoons. Monsoons are seasonal wind patterns that bring about significant changes in weather conditions. They are characterized by a seasonal reversal in wind direction, which lead to wet and dry periods in various parts of the world. Monsoons are often associated with heavy rainfall and play a crucial role in climate agriculture of many regions, such as South Asia.
Monsoons are large-scale sea breezes that occur when the temperature on land is significantly warmer or cooler than the temperature of the ocean. These temperature imbalances happen because oceans and land absorb heat in different ways. Over oceans, the air temperature remains relatively stable. There are two reasons for this. Because water has a relatively high heat capacity, and because both conduction and convection will equilibrate a hot or cold surface with deeper water. Oppositely, dirt, sand, and rocks have lower heat capacities, and they can only transmit heat into the earth by conduction and not by convection. Therefore, bodies of water stay at a more even temperature, while land tends to vary in temperature. During warmer months, sunlight heats both land and ocean surfaces, but land temperatures rise more quickly. As the land's surface becomes warmer, the air above it expands and an area of low pressure develops. Meanwhile, the ocean remains at a lower temperature than the land, so the air above it retains a higher pressure. This difference in pressure causes sea breezes to blow from the ocean to the land, bringing moist air inland. This moist air rises to a higher altitude over land, and then it flows back toward the ocean, completing the cycle. However, the air cools when it rises and while it is still over the land. This decreases the air's ability to hold water, causing precipitation over the land. In the colder months, the cycle is reversed. Then the land cools faster than the oceans, and the air over the land has higher pressure than the air over the ocean. This causes the air over the land to flow to the ocean. When humid air rises over the ocean, it cools, and this causes precipitation over the oceans.
Ipo-ipo. Ipo-ipo is a Filipino term that refers to whirlwinds or dust devils. These are small-scale whirlwinds characterized by swirling dust or debris. They're not as destructive as tornadoes or hurricanes, but can still be hazardous in certain situations.
Tornadoes begin with a thunderstorm, but not just any thunderstorm. These are especially powerful, towering thunderstorms called supercells. Reaching up to over 50,000 feet, they bring high-force winds, giant hailstones, sometimes flooding, and great flashes of lightning too. These are the kinds of storms that breed tornadoes, but only if there are also very specific conditions in place, clues that we can measure and look out for when we're trying to forecast a storm. Rising air is the first ingredient needed for a tornado to develop. Any storm is formed when condensation occurs. The byproducts are the clouds. Condensation releases heat, and heat becomes the energy that drives huge upward drafts of air. The more condensation and the bigger the storm clouds grow, the more powerful those updrafts become. In supercells, this rising air mass is particularly strong. As the air climbs, it can change direction and start to move more quickly. Finally, at the storm's base, if there is a lot of moisture, a huge cloud base develops, giving the tornado something to feed off later if it gets that far. When all these things are in place, a vortex can develop enclosed by the storm and forming a wide, tall tube of spinning air that then gets pulled upwards. We call this a mesocyclone. Outside, cool, dry, sinking air starts to wrap around the back of this mesocyclone, forming what's known as a rear flank downdraft. This unusual scenario creates a stark temperature difference between the air inside the mesocyclone and the air outside, building up a level of instability that allows a tornado to thrive. Then, the mesocyclone's lower part becomes tighter, increasing the speed of the wind. If, and that's a big if, this funnel of air moves down into that large, moist cloud base at the bottom of the parent storm, it sucks it in and turns it into a rotating wall of cloud, forming a link between the storm that created it and the earth. The second that tube of spinning cloud touches the ground, it becomes a tornado. Most are small and short-lived, producing winds of 65 to 110 miles per hour. But others can last for over an hour, producing 200-mile-per-hour winds.
Flooding. Flooding, on the other hand, is the overflow of water onto land, often due to heavy rain, storms, or other factors, resulting in the inundation or areas not typically submerged.
Floods can form after heavy rain over a long period or when a large snowfall melts. There are many different types of flooding which fall under three main categories. The first results from overflow. After heavy rain, a river can burst its banks. The water can engulf entire valleys far from the precipitation zone. Other tributaries add to the flow of water, worsening the deluge further downstream. The second type of flooding involves the accumulation of water in lowlands or basins. In normal weather conditions, water is absorbed into the ground and merges with the water table. When the ground is saturated, water builds up in low-lying areas. Runoff then quickly fills the valley and its waterways. The third type is caused by urbanization in flood-prone areas. Excess water passing through drainage systems can accumulate in low-lying zones. This effect is worsened by the coverage of land with buildings and impermeable surfaces such as concrete. Less water can be absorbed into the ground, overloading sewers.
Philippines is a prone tropical cyclones due to its geographical location, which generally produce heavy rains and flooding over large areas, and also strong winds which result of heavy casualties to human life and destruction of crops and properties. Thus, it is utmost important to have efficient knowledge on such maritime phenomena of beneficial for us. Hazard maps are developed to identify areas that are affected or vulnerable to a particular hazard. They are typically made of nature hazards such as earthquake, ground motion, flooding, landslides, wikifunction, tsunami, and others. These maps, when properly utilized by developers and engineers, can be saved life and economic losses by avoiding exposure to some hazards.
Marine and coastal process and their effects. The rise and fall of ocean water under the influence of the gravitational pull of the moon and sun creates tides. This coastal process produces periodic change in water level in different parts of the foreshore being exposed to wave and energy throughout the day.
Ocean waves erode and shape the world's coastlines because the water within the wave moves up and down. Ocean waves will not be produced if there is no wind. The wind that blows over the top of the ocean creates friction between the air and water molecules, creating a frictional drag that shows up as wave on the surface of the ocean.
Storm surge. This hazard is also described as coastal flood or tsunami flood phenomenon happens when there is rising of the sea as a result of atmospheric pressure variation and heavy wind associated with the storm. The two main meteorological factors contributing to storm surge are a long fetch of winds spiraling inward toward the storm and a low pressure induced dome of water drawn up under and trailing the storm center.
Hazards brought by the different coastal practices. First, we have coastal erosion. Coastal erosion is the wearing away of the land by the sea and is done by destructive waves. Five common processes that cause coastal erosion. Number 1. Corrosion. Corrosion is when waves pick up beach materials and hurl them at the base of a cliff. Number 2. Abrasion. Abrasion happens when breaking waves containing sediment fragments erode the shoreline, particularly a headland. It is also referred to as the sandpaper effect. Number 3. Hydraulic action. The effect of waves as the hit cliff faces, the air is compressed into cracks and is released as waves rushes back seaward. The compressing and releasing of air as wave rests cliffs faces and rushes back to sea will cause cliff material to break away. Number 4. Attrition. Attrition is the process when waves bump rocks and pebbles against each other, leading to the eventual breaking of the materials. And lastly, number 5, corrosion or solution, involves dissolution by weak acids such as when the carbon dioxide in the atmosphere is dissolved into water, turning into a weak acid. The rate of dissolution is affected by the concentration of carbonates and other minerals in the water. As it increases, dilution becomes lower. Second, sediment movement along coast. As wave crashes on the shore, the water pushes sediment up the beach and then pulls back down the beach as the water slides back down. If the waves do not come in parallel to the beach, longshore transport or literal drift of sand occurs. Third, coastal deposition. When waves lose their capacity to carry or transport sediments because of a reduction in energy, they can and will drop or deposit its sediments load. Waves that do not have the capacity to transport sediments and which results to sediment deposition and accumulation are called constructive waves.
Submersion. Submersion is described when sediment is submerged underwater and eventually replaced back to its original location. This often takes place during violent storms when sand is dragged or pushed underwater, and it tends to return back to the visible place via wave action it had previously been when the seas have calmed down.
And lastly, saltwater intrusion. Saltwater intrusion is defined as the flow of seawater into freshwater bodies like rivers or aquifers due to natural processes or human activities. It is a major concern for most coastal areas as it can induce contamination of water resources and therefore drinking water and may cause damage to agriculture.
The groundwater that people in the Soquel Creek Water District use is stored between rocks and sand. Rainfall seeps into the groundwater aquifers and slowly flows underground to the ocean, or returns to the surface as a spring or directly into a river before reaching the ocean. The freshwater underground creates a buffer near the shore where freshwater and salty ocean water meet. When wells draw more water out of the ground than is naturally replenished by rain, groundwater levels begin to drop. Salty ocean water moves inland and mixes with the fresh groundwater. As seawater moves inland, wells that once drew fresh drinking water become salty and unusable.
Prevention or mitigation of the impact of land development, waste disposal, and construction of structures on coastal processes. Reasons why coasts are modified. First, residential, recreation, and tourism. Second, shipping and transport. Third, gain more land. Fourth, protect beach properties. And lastly, preservation of cultural or historical landmarks.
There are two types of coastal management: hard engineering and soft engineering.
Hard engineering. This involves building structures to protect the coast. Soft engineering. This involves working with nature by using natural materials or allowing nature to take back areas.
Four types of hard engineering. Number 1. Seawall. Seawall placed at the base of a cliff to reflect the wave's energy. Number 2. Gabions. Gabions, cages of wire filled with rocks to absorb the wave's energy. They are effective and cheap but environmentally ugly. Number 3. Groins. Groins can be made of wood or rock and are long vertical structure placed at right angles to the beach to trap sediments. This builds up the beach and protects the cliff from erosion. They are effective at building up the beach, therefore protecting cliffs from wave attack. Number 4. Riprap or rock armor. Large rock placed at the bottom of the cliff to absorb the wave energy. They're effective at dispersing the wave's energy and cheap, environmentally ugly, and may put off tourists. Also, 4 types of soft engineering. Number 1. Beach nourishment. Large amount of sand are added to the beaches to build them up and help absorb wave energy. This protects tourism as well as the coast and easy to carry out and fairly cheap. But it is not very long as sand will continue to be transported along the coast by longshore drift. Number 2. Manage retreat. This allows the natural erosional processes of the sea to occur. Areas of low-value land are allowed to flood, hopefully protecting more important areas further down the coast. Cliff stabilization. Cliffs are covered in matting and vegetation planted to help them make them more stable and resistant to erosion. Number 4. Do nothing. Obviously the cheapest and most environmentally friendly option. However, you have to weigh up the costs to people, tourism, and buildings against the benefits, advantage of letting the area to return its natural processes.
And this is the end of our discussion. We hope you learned something from us. Thank you!